Hi Year 11, I'm going to go through some examples of using the alternate segment theorem. Okay, so we've got an example here with a triangle and a tangent, and that's what we're looking for to apply the alternate segment theorem. Okay, we've got to find x. So in the alternate segment theorem, I advised you yesterday to do some colouring in. So if you look at the side that's got if you look at the tangent and look for the angle that's marked in, and then colour in that segment, okay, that the angle's in. Now, alternate means like the alternate one, like alternatives. Okay, so the alternate segment theorem tells us that this 64 is equal to the angle inside the other segment. So the other segment, it has to be this angle here. Okay, so over here we'll have 64 degrees. Right, and then we have a triangle, don't we? So we've got give reasons for your answer, so it'll be alternate segment theorem. You probably have to write the words. Okay, and then the next thing is angles in a triangle. We've got 180 minus 64 and minus 43. So that's take away 107, isn't it? So 73 degrees, I think. 73 degrees for x. Okay, let's look at the next one. Find the angle marked y, give reasons for your answer. Right, so this time I'm going to colour in the angle that's marked between the tangent and the chord. So I'm colouring it in. Alright, so that's this segment. The alternate segment is the other one, and so that means that this 46 degrees is it's going right across from the edge of the chord, from the edges of the chord, it's the lines going right across. So it's not this other one up here at all. Okay, so y, they've given you some like things to throw you off the scent, but y is going to equal 46 degrees from the alternate segment theorem. Okay, so that one's a little bit trickier, even though it's actually less calculation. Okay, I'm going to just pull us onto the next questions. Okay, so I'm going to find A. Let's do some colouring in again. Okay, right, so angle A between the tangent and the chord, I'm going to colour that segment in. So the alternate segment reaches from the edges of the chord, so in fact 41 degrees is that alternate segment. So A is 41 degrees. Okay, let's look at the next one. Right, so here's our tangent and our chord. We colour in that segment, and then if we stretch from the edges of the chord, stretch the elastic right across, then that tells us, the alternate segment theorem tells us that B is the same as 46. 56, I can't read, dear me. Right, okay, this one looks a bit weird, doesn't it? We've got to find C. Let's do our colouring in first. Okay, so here's our tangent. Here's our chord going up to 42. We're going to colour this bit in. So there's our segment we're colouring in. So if we stretch elastic from the edges of that segment, that chord, right across, okay, then that tells us that this angle is the alternate angle, and it will be 57 degrees. It's the same as the one we coloured in. Right, then we have got a couple more bits of information. Now, we know that all angles in a triangle add up to 180, so that's good. But we don't know this little missing bit here, do we? But if you see a right angle, draw it in. That's what we did on the previous one. Here's our right angle. Okay, because this is a radius and this is a tangent. So that means 57 and the one we don't know add up to 90. So if I do 90 minus 57, what am I going to get? 33? Okay. Right, now all of those angles in the triangle add up to 180. So we do 180, take away what we've got, 57 and 42 and 33. Actually, we know 57 and 33 adds up to 90. So we've got 132. So we have got 48 degrees for C, I think. You might want to check it on the calculator. Okay. Right, let's look at D. So we have an angle between the tangent and the chord, and we colour in that segment. And we reach from the ends of that chord right across with a piece of elastic to the opposite side. There's our alternate segment. Okay, so this is 41 degrees up here. Right, now then, we know we've got a triangle, but we don't know the angle over here, but you can see we've got a quadrilateral, and these angles opposite in a cyclic quadrilateral add up to 180, so that's got to be 76 degrees. And there's our triangle, so if we do 180 minus 41 and minus 76, that's going to give us 63 degrees, I think. You're best checking my adding up, I'm doing it in my head. Okay, let's try a last few questions, they're getting trickier. So the diagrams look more complicated, but you have to look for things you know. Right, here's a tangent, here's a chord, and we've got an angle coloured in there, so we're going to colour in that chord, that segment, sorry. Now, if you reach from the corners, from the edges of the chord right across the circle, then you get this whole angle over here. So that big angle over there is going to be 52 degrees. I'll just put it lightly at the minute. Oh, and we need to find E. So we've got to find some other things to help us. Right, so can you see that we've got the centre marked in? And we've got an angle at the centre and facing the same way, so inside the same segment as the one in the centre, we have got 71 degrees. So what's our rule? The angle at the centre is double the angle at the circumference. So this is going to be 142 degrees. This is a radius and that's a radius. So this and this are the same, which makes an isosceles triangle. So we can find the little angle here, and that's going to help us, isn't it? So each little angle will be the same. If we do 180, take away the 142 and half it, then we're going to get 38 halved, which is 19 degrees. And so that means that E is going to be 52 degrees, which we got earlier on, minus 19 degrees, which is going to be 33 degrees. Okay, let's have a look at F. I think it's pretty similar. So we have a tangent and we have a chord. We have an angle marked there, so we're going to colour in that segment. Okay, right, now that means that all of the other side of the chord is the alternate segment, and if we stretch from the edges of the chord right across the circle, we get to, what's this, 60 degrees right over here. So that includes the F. Right, now again, we've got a centre marked and we've got an edge marked. So let's see what we can do there. So the angle at the centre is going to be double of the angle at the edge. So we're going to have 112 degrees. Then we have got an isosceles triangle, okay, and so we can work out those two matching angles. If we do 180 minus 112 divided by 2, somehow I've drawn myself a box. Okay, right, let's just think. 68 divided by 2, 34. Okay, so that little bit here is 34. And 34 plus F makes 60. So that means that F has got to be 26 degrees. Okay, right, let's have a look at the next one. We have a tangent, we have a chord, so we colour in this segment where the angle is marked. Then we look to where we stretch right across. We can see that the angle here is going to be our matching 45 degrees. Now if we're finding G, we have a triangle here, but we don't know the missing angle there. Okay, but it's like one we did before. You can look at the four-sided shape. So cyclic quadrilateral, the numbers add up to 180. So this is going to be 74 degrees. So then if we want G, we're going to do 180 minus our 45 and minus our 74, which should be 61 degrees, I think. Right, last one. So we have a tangent, we have a chord, we have an angle marked, so we're going to colour in that segment including that angle. And then if you're reaching right across from the edges of that chord, you reach this angle here. So this angle's the same one, 68 degrees. Now we've got to find H. Now I'm looking and I could see a little triangle here, and I could find the angle in the bottom of the triangle, and then we're on 180. Okay, so if I know I could do 180 minus 68 minus 30, okay, and that will give me the angle down here, and then I do 180 minus that, so I get back to whatever 68 plus 30 is. You can do it if you want to, okay, just to show you that's the same as minus 68 plus 30, which is 98. Okay, and then we would be finding 180 minus all of that, so we get 98 for H. You can do the calculations to convince yourself if you want to. Okay, I think that's the hardest theorem, so well done.